Okay, welcome back. We're going to continue our discussion on bonding, and we're going to first learn how to make compounds before we can actually continue naming them. Okay, so that's important. All right, so with that said, let's turn our attention back to the last thing I said is in ionic bonds the electrons are not equally shared. What do we really mean is once a metal and a non-metal fuse together and make an ionic bond, okay, let's say sodium, okay, this is ground state sodium, it's got 11 total electrons, but its group number is 1a, okay, its group number is 1a. That means it can only lose one electron, okay. Now, let's say this is going to combine with chlorine, which is I believe 17, and I believe it is, if I bring the periodic table, I think it is 7a, right? 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 Now, keep in mind it is not going to lose 7 because it's a non-metal, right? Right? So, it's going to gain 1 electron to get to that magic number of 8, right? To go from 7, it needs 1 electron to get to 8. Now, where is it going to get that 1 electron? Well, you guessed it. When sodium and chlorine are going to combine, that 1 electron lost by sodium is what's going to combine with the chlorine. Now, we have now you would think, well, you said that 2 electrons make a bond, right? Now, let's put it all together in perspective. Now, sodium, okay, it's losing its 1 electron, so it's going to be plus 1, right? And chlorine is gaining 1 electron, so it's going to get 1 minus, right? Now, remember I said these 2 electrons make a bond, right? So, in case of an ionic bond, yes, this does exist, but it's kind of virtual, like I am donating, you're accepting, and this is continuously happening, okay? It is, but what happens here is, if say this was this bigger in size and this was like that, okay, what happens here is whenever an element loses electrons, it becomes smaller, okay. So, that means sodium now has become smaller and chlorine now has become bigger, because electrons, when you add something, like say when you blow air into a balloon, it's going to get bigger. It's the same thing, when you add electrons into an atom, it's going to get bigger. When you lose electrons, well, obviously if you let go of the air in a balloon, it's going to shrink, right? That's exactly what's happening here. So, the sodium is giving its 1 electron and the chlorine is actually accepting that electron, okay, making a bond. So, in case of an ionic bond, we don't really draw a full bond, we kind of draw it like this. Does that make sense? You still use the same 2 electrons, but what has really happened is chlorine is really not donating anything, it is simply accepting that 1 electron donated. So, it's kind of a mutual interaction, but you also should notice sodium, which was bigger, has now shrunk, and chlorine, which was smaller, has now grown bigger, okay. So, in ionic bonds, we don't really draw a solid line, we just draw a wedge line. Of course, if you draw a solid line, it's not going to entirely say that your content is incorrect or anything, but this is conventional, okay. And whenever we write ionic compounds, we don't just say, I mean, you do see people write NaCl, of course that is perfectly all right. Now, there's also one more way to do it, okay, because it's generating, because the electrons are neither towards one atom, okay, it's kind of pushing towards the chlorine, but it's kind of trying to stay with sodium. So, people also have seen, right, delta, which is a positive partial charge, and chlorine, which is a partial negative charge, okay. Both are correct. Okay, whichever one you like you can use. If you want to be a little fancy, you can write it this way. So these are ionic compounds. Okay, we're going to come back and do a couple more examples. Okay, all right, I'll be back.